Hello, this is the lesson for Unit 73, Drilling and Boring Compound Angular Holes, Computing Angles of Rotation and Tilt using given lengths. So here we will continue with the rectangular solids, and inside this solid we have the right triangle ABC. And through this rectangular solid we want to drill a hole, and the axis of this hole is the diagonal AB. Imagine that the tool that drills the hole works only vertically, starting drilling from the top and going perpendicular to the ground. Therefore, we will need to rotate and tilt this rectangular solid. And now we will try to explain something that you have on page 528, and that is the procedure for positioning the part on an angle plate for drilling. So imagine that here we have the pivot axis of the angle plate. Now look at the bottom front edge of this solid that I am highlighting right now. Can we say that this edge is perpendicular to the pivot axis? Yes, it is. The same is the back edge. So this one is also perpendicular to the pivot axis. But what about side CB? CB is not perpendicular to the pivot axis. Now imagine that we have to take this whole solid and rotate it until this side CB is perpendicular to the pivot axis. This angle of rotation that makes the side CB perpendicular to the pivot axis is called angle R, and here it is. This is angle R. And if that is angle R, then this one is also angle R because of the alternate interior angles. So angle R represents the angle of rotation. But now we still have to tilt the rectangular solid because we need this axis of the hole AB to be vertical. In other words, to be perpendicular to the horizontal surface. And we see inside this right triangle that the angle of tilt is called T. So in this unit we will work on finding these two angles, the angle of rotation and the angle of tilt. Please read page 528 to get a better understanding of the angle of rotation and the angle of tilt. Now let's see exercise 7 on page 530. So we will use this solid to the right, and the height is 2.6 inches, the length is 2.4 inches, and the width is 1.9 inches. First we have to compute the angle of rotation R, then we have to compute the angle of tilt T. Let's start with the angle of rotation. To find angle R, we will use the tangent function. Tangent of angle R equals the opposite side, which is W, divided by adjacent side, which is L. Replace W with 1.9 and L with 2.4 and take the tangent inverse of this expression and get that angle R equals 38 degrees and 22 minutes. Now the angle of tilt T is the angle that is inside the triangle ABC, and so far what we know about this triangle, we know that the side AC is the same as the height and is 2.6. And to be able to find an angle, we need to know two sides. So first we will find the side BC. So these steps are very similar to the ones in the previous unit. So here to the right we have that BC squared equals L squared plus W squared. Replace L with 2.4 and W with 1.9. Then BC will be equal to the square root of 2.4 squared plus 1.9 squared. And here we get that BC equals 3.06105. Now let's find the angle of tilt. The tangent of this angle is the opposite side BC divided by the height h. Replace BC with 3.06105 and h with 2.6. Then to find the angle, take the tangent inverse of this expression, and we will get that the angle of tilt is 49 degrees and 39 minutes. So this was exercise 7 on page 530. Exercise 9 on page 530 is an exercise very similar to the previous one. The height of the rectangular solid is 4.75 inches, the length is 4, the width is 3.75 inches. We need to compute the angle of rotation R and the angle of tilt T. So let's look closer at this picture. So here we have angle R, then tangent of this angle R equals the opposite side W divided by adjacent side L. Now we will replace all this in the formula. So tangent of R equals W over L. W is 3.75, L is 4. Then down here we will take the tangent inverse of this expression, and we will get that the angle of rotation is 43 degrees and 9 minutes. And now in part B, to find the angle of tilt, first we have to find the side BC. So BC squared equals L squared plus W squared. Replace L with 4 and W with 3.75 and find side BC by taking the square root of 4 squared plus 3.75 squared. BC equals 5.48293 inches. Now in the triangle ABC, we know the side BC and we know the height, which is AC. So to find the angle of tilt, tangent of this angle equals 5.48293 divided by the height, which is 4.750. Take the tangent inverse and get that the angle of tilt is 49 degrees and 6 minutes. This was exercise 9 on page 530. Here we have exercise 13 on page 531. The top, front, and right side views of a compound angular hole are shown. Part A. Sketch, dimension, and label a rectangular solid. Within the solid, show the right triangle that contains the whole axis as a side and the angle of tilt. Show the position of the angle of rotation. Part B. Compute the angle of rotation R. Part C. Compute the angle of tilt T. So let's analyze the views that we are given. The first one is the top view. That white circle, that is where the hole starts from the top. So we see that the hole starts from the left in the back and comes down to the right in the front. Now the second view is the front view. In the front view, we see that the height is 2.5 and the length is 1.1. It also shows the axis of the hole as we see it from the front. So from the front, we see that the axis of the hole comes from the upper left and it goes down to the right. And the last image represents the right side. On this image we see the width, which is 0.6. From this right view we see that the axis of the hole comes from the upper right and goes down to the left. Using all these three views, we have to construct the rectangular solid. And within the solid, we have to draw the right triangle and the axis of the hole. So let's see then what we have in the solution. So take a moment and see if all these three views match the rectangular solid and the triangle inside. Now to find the angle of rotation, we will use the tangent. And it looks like I put too many zeros in there. I will fix this in a moment. Okay, so here I fixed it. 0.6 divided by 1.1. To find r, take the tangent inverse and get that angle r, which is the angle of rotation, is 28 degrees and 37 minutes. Now before we find the angle of tilt, we have to find the side BC. And the side BC is the square root of 1.1 squared plus 0.6 squared. We get BC here, it's 1.253. And now we can find the angle of tilt. Tangent of angle T equals BC divided by 2.5, which is the height. And take the tangent inverse to get the angle of tilt. And the angle of tilt will be 26 degrees and 37 minutes. Okay, and this was the whole problem 13 on page 531. Now we are done with Unit 73, drilling and boring compound angular holes, computing angles of rotation and tilt using given lengths. Thank you for watching.